Welcome participants to this NPTEL offered course on conditioning program designing. We are in week 2 and I am Wing Commander Chandrasekhar Guru. We are discussing about the application of periodization principles in this conditioning program designing. So today you are here for lecture 3 of week 2 where we will be discussing about various principles of periodization. The learning objectives of today's lecture would be to understand the foundational principles of adaptation, relating the principles of training with periodization for implementation. We will also discuss the principles in hierarchical structure of periodization and application of the principle in the periodization of biomotor qualities. So, periodization is the blueprint for optimal adaptation. It manages the workloads of all training factors. The goal here is to direct adaptation and elevate performance at the appropriate time. So, that is the crux of periodization. The training must progress in a systematic way to induce superior adaptation and ultimately lead on to improved performance. An inability to adapt to varying training loads to critical levels of fatigue or overtraining can also happen if the training load is not properly managed. So, the training plan must be logically constructed and appropriately sequenced to manage the fatigue and elevate that level of readiness for that highest level of performance during competition. So, in nutshell, periodization is equal to planning, that is into phases, plus programming using training variables to have adaptation as well as avoiding the fatigue. So, the goals that is derived from the periodization principle are optimization. So, you maximize the athlete's performance capacity at the predetermined time or maintain performance across a season. So, that is how you try to optimize the athlete's performance capacity. The second goal is to targeted development. So, develop specific physiological and performance outcomes with precise training interventions. So, that helps in having a targeted development of the biomotor quality. Stress management, reducing the overtraining potential through the appropriate management of training stressor. So, if you modulate this, you manage the stress as well. The final goal derived from the principle is adaptation management. In fact, the structure manages the recovery and adaptive process to ensure peak performance only for a short time. So, it is between the 8 to 14 days. So, that is what the goal is, to use the periodization principle in the conditioning program designing. So, when you speak about adaptation, it is important to know the basics of how adaptation happens to a training stimulus. There are various theories that has been put forward which are the foundation for any periodization principle. So, we will discuss about these theories. The first one to discuss is the general adaptive syndrome, the theory developed by Hans Selye. So, it is the foundational theory which underpins the periodization of training. Here the theory helps to explain how the body adapts to the training stimuli. Basically, the concept is, it describes the body's specific responses to stress. The stress may be a physical stress or a physiological stress or maybe an emotional stress as well. All stresses kind of add on to have certain adaptation. So, the application of this particular aspect is that the body responds similarly regardless of the stresses being applied. The external stressors may be emotional, may be psychological, and can be physical. All the stresses will be additive and it can affect the athlete's overall ability to adapt. That is what you will have to understand. So, let's see this is a training stimuli given over time. So, with the time, so as per this theory, the individual immediately respond to a training stimuli. So, that leads on to a immediate dip in the level of performance where the individual is trying to resist that stimuli given, and thereafter he reaches to a new level of performance. Let us divide that into 3 different parts. So, the curve A here denotes a typical training where you do not give adequate time period for adaptation. So, definitely it gives a better output, but then it is not that much. Whereas, if you go for incorporating the principle of overloading, training principle, using this theory, it shows that after the initial alarm phase, the individual, the body goes into something called as resistance or adaptation phase. And if adequate time is given during this phase for the adaptation to take place, the individual may end up into a new level of performance. How you see it as elevated from the initial level of performance. However, if the training stimuli is given before that period when the individual has completely or adapted, so that may end up in something called as overtraining or exhaustion. So, that is denoted as a which results in a level of performance which is lower than the actual original level of the individual's performance. This particular graph is being specifically adapted from Tudor Bumpa's periodization textbook. So, what it means? So, in the alarm phase, that is the phase 1, it is the initial response which occurs immediately when a new training stimulus is given to that particular individual. This results in an initial reduction in performance because of the acute fatigue that has set in, soreness and stiffness of the musculoskeletal system. So, that causes a reduction in the availability of energy stores as well. So, that is the reason for a immediate dip. It becomes a trigger also. So, whenever there is an immediate assault, the body tried to kind of resist that. So, this initial phase helps the body to process and leads on to the next process called as the resistance phase. This initial drop in performance is expected when introducing a new stressor, whether it is a new type of activity or high volume in a microcycle. So, when it moves on to the next phase called as the resistant phase, the resistant phase where the adaptation occurs here. So, this is the phase when the adaptation happens and it leads on the system either back to baseline or in most of these instances to a new level of performance above the baseline. So, this is the concept of supercompensation. It is the relationship between the work and the regeneration that kind of leads on to a superior physical adaptation. So, good planning, alternating the training load in terms of high, moderate and low kind of is necessary to facilitate this important aspect of supercompensation, because when we are designing a program, we are looking at a new level of improved performance, right. So, to reach there, it requires a lot of planning to vary the variables in terms of intensity or volume. A successful training program, if programmed correctly, the athlete's overall performance capacity will definitely be elevated from the baseline. It is called as super compensation. However, there is another phase of overtraining or exhaustion. If the individual fails to adapt or adequate time is not given or the stimuli is over and above the capability of the athlete, that can result in what you call as failure to adapt. So, that results in exhaustion. So, the consequence of that is a decline in the performing or performance capacity. So, this is one of the important aspect that one has to keep into consideration whenever you are involved in planning and designing of a conditioning program. So, how can you prevent it? It is just that by monitoring and giving the right amount of stimuli at the prescribed time, so that the variability that is introduced here will help in preventing the occurrence of overtraining. Moving on to the other theory, the second theory is the adaptation theory, that is stimulus fatigue recovery adaptation theory. Herein this theory explains the general response pattern that occurs when a training stimulus is applied. You apply a training stimulus, there is fatigue which happens because of the immediate training stimulus. There is a period of recovery, the body tries to recover and then it adapts to a next new level. So, that is the sequence of SFRA theory. Here the fatigue is proportional to the workload, that is magnitude and the duration of the workload. So, the workload determines the fatigue level. So, preparedness are the two concepts here. So, if you have a good recovery with the accumulated fatigue being lower, the preparedness level is said to be higher. Whereas, if there is inadequate stimulus or no stimulus given during the period of recovery, there may be complete recovery. So, the individual may actually lose out on the adaptive changes that have happened and is said to be in a lower level of preparedness or involution. So, this particular theory helps in framing the concept of giving the stimulus at the right time for having the right kind of preparedness for peaking. So, this particular graph shows how the entire structure is divided into these 3-4 phases. So, initially you have an acute response after the stimulus training, which leads on because of the fatigue that ensues in the athlete's body. Subsequently, after a period of time, there is recovery which helps in improving the graph to the baseline. So, that is the recovery phase, and if the recovery is adequate and the stimulus or the workload is accordingly manipulated, there is compensation wherein the individual reach to a new level of performance. However, in case and the individual is said to be in a good level of preparedness, right. If the individual kind of the stimulus is not given at the right time or at the right amount magnitude, so that may result in lower preparedness or decrease in the performance level. So, that is how the concept of adaptation and aiding in terms of recovery and performance is explained using SFRA theory. How do you apply this? So, as per this, it is the theory basically to help you understand the recovery time. So, workload is directly proportional to the recovery time. So, there is something called as a delayed training effect, wherein manipulation of this workload becomes the key at what time you are doing. So, that helps in kind of coming on to a process called as super compensation. It also helps in kind of managing the fatigue. So, when the individual is in a state of incomplete recovery, you can give a stimulus, but then the stimulus, the magnitude should not be too high. It should be at an appropriate level that it can even kind of help in kind of adapting to the next training stimulus. Load modulation. So, it also is an important concept in terms of managing the fatigue, wherein you try to modulate the load in terms of the intensity as well as in terms of the duration. How you can modulate it to allow the body to kind of recover and adapt to a new performance level. So, these principles are applied whenever you are kind of planning and designing a conditioning program. The last theory which is related to this program designing is fitness fatigue paradigm. That is, it basically states the relationship between the fitness, fatigue and preparedness. So, all these theories are more or less interlinked, just that it helps you to understand the concepts, how important these concepts are. Here it means that the training increases both the fitness as well as the fatigue. So, these are two different outcomes because of the training. So, if you are expecting to have a positive or an optimum performance, it is said that the fitness should be larger and fatigue should be smaller, so that the difference between fitness and fatigue determines the performance. So, in simple terms, if the recovery reduces the fatigue level and it helps in revealing the fitness level. So, the sequence here would be again training stimulants leading on to fitness, then going on to a recovery stage and then adaptation taking place to a fitness level, new fitness level. So, that is the sequence. with respect to the fatigue, fatigue is proportional to the workload that is given, the magnitude and the duration. What do you mean by the preparedness? Again, it is denoted with respect to the recovery. With the recovery and the accumulated fatigue decreases, right? So that means the individual is well prepared. If there is no stimulus, this complete recovery, then the preparedness will be lower. So this is almost in line with what the previous theory also mentioned. So here it is more of focusing on fitness and fatigue. If you want to address the fatigue, then you will have to kind of manipulate the load. If you want to address the recovery, you will have to again it depends on the time duration that you allow for the adaptation to take place. So with this fitness fatigue paradigm, you give a training stimulus, gradually with the initial training stimulus the fatigue is more, and with the adaptation it reduces over a period of time. And the opposite thing happens with fitness level. Initially with the training level, gradually the fitness level also comes back to the baseline. So if the preparedness is again denoted by the increased preparedness as the individual kinds of undergo the training over a period of time. So if you are able to balance the fitness level and the fatigue, you will be able to go to the higher level of preparedness. So the residual effect will be a higher level of preparedness compared to the baseline. So here it is important to note that when the fatigue disappears faster than the fitness, that it means that you are prepared better. So the focus should be in terms of addressing the fatigue as well as also to give additional training stimulus for the fitness also to improve. So this particular picture is adapted from Mike McKagan NCA's Developing Power. So what is that paradigm actually helps you out in applying? So different training targets, for example strength, speed, have different after effects and decay rates. So you cannot universally apply this concept for all the biomotor quality. So you will have to know which particular kind of biomotor quality will have a longer fatigue period. So accordingly you will have to plan the next kind of training stimulus in the form of load. So that is how the application of fitness fatigue paradigm. And all of us know that all of us are not same, and one particular size doesn't fit all, right? So every individual has to be seen as a different with a different unique qualities and characteristics. So the response may vary with respect to the biomotor quality as well as with the different training. So accordingly you will have to manipulate that particular aspect to address this fatigue decay time. Residual training effect, if you see, the after effects because of the training is also is the foundation for planning the next particular block of microcycle or the mesocycle. So that is again an important take home from this fitness fatigue paradigm. It also helps in kind of sequencing your program, say that decay rate of a residual training effect can be maintained by minimal training stimulus or periodization. So if you find that a particular biomotor quality has a longer decay period, so you can actually sequence a lighter load or train a different quality so that you don't kind of end up in overtraining. It also is an important concept called phase potentiation. So with this theory we can understand that correct sequencing of specific training stimuli can actually magnify the residual effects. If you are able to use the right kind of goal for that particular subgroup of phase, it can help in kind of leveraging to the next particular the training effect can be leveraged as a stepping stone for the next particular goal that you are assigning. So you will be kind of explained and more in detail you will be able to understand in the subsequent weeks when you practically use these principles in designing the training program. So how is the implementation of these principles of periodization in when you kind of plan the conditioning program? So you will have to use the consists of training variation to prevent the monotony and reduce the injury risk through the use of different type of exercises. Sequencing, again managing sequencing in terms of managing the fatigue level, that is your recovery status, and the adaptation by organizing the training phases logically. The third important aspect is the individualization, where you need to pay heed to the individual response of the athlete as well, and as well the biomotor quality. The individual biomotor quality will have a different decaying effect. One also needs to pay attention to the training age, because that again is an important factor that gives you cue to adjust your or designing your training program based on the experience level as well. So, training age is an important factor when you consider conditioning program designing. So, one important principle that you need to also incorporate in your conditioning program designing is the specificity in the adaptation. So, adaptation is highly specific to what type of training that you are giving. So, that principle is called as SAID principles, that is specific adaptation to the imposed demand. So, if I lift weight, so I expect that my muscle hypertrophy happens. You cannot expect by lifting weight that your cardiorespiratory fitness will be good to run a marathon. So, specific type of adaptation will happen to imposed demand, that is important. The focus areas would be to focus on the bioenergetic system that you want to specifically train for that particular sports, the skills that are required for achieving optimal performance for that particular sports, and the sports needs, the motor qualities that will determine the maximizing the performance for that particular sports. So, all these three areas have to be specific in terms of your training methodology. That such kind of a training will kind of produce a physiological change which is specific in terms of the muscular, metabolic, cardiorespiratory adaptation. So, these depends on more of the programming variables. So, that is how it is important. Learning or knowing these things, it is useful in framing your programming variables. So, an example would be to in endurance training program, you have to stimulate the adaptation which are more in terms of increasing the capillary networks and oxidative efficiency, right. Whereas in strength training, your target is mainly to address to the neuromuscular system, mainly the muscular system and the nervous system, and enhance the capacity to perform anaerobic work. So, two different aspects that one needs to kind of pay attention to when you are applying the concept of periodization in conditioning programming. How about the hierarchical principle of periodization? As we discussed previously, it has to go from global to specific. So, we discussed about the biomotor ability in the previous lecture. So, you start from foundational skill, then move on to a strength focused thing in the next subphase, then move on to specific sport specific subphase. So, that is how you kind of have a broader requirement and break them into smaller goals, and then you reach to the final goal. So, it should be global to specific. The program should incorporate the principle of periodization in terms of multilateralism to specialization. So, when you are addressing initially, the conditioning should be more of a broad based conditioning to give an anatomical adaptation as a whole, and based on those developed basic foundation, you move on to the specialized biomotor skill that is required, and they can be sequentially planned for having those various effects that we discussed previously. And last important principle that you need to apply is the concept of progressive overload. If you are not able to improve or increase the load sequentially over a period of time, the outcome also may not be that good. So, it can be managed by varying the intensity, volume and the frequency of the programming variables, right. So, the load progression can be a standard loading, but then it can lead on to something called as performance plateau. It can be linear loading, where you keep on loading it over a period of time linearly. So, that can lead on to something called as overtraining risk. It can be step loading where you have a 3 microcycle is to 1 microcycle lower. So, you have a linear loading and then a break. So, it's kind of a U-shaped structure that you can see. It can be a concentrated loading where it can be more of a block based training concentrated in multiple peaks. Maybe you can have this type of load progression, but then you need to give adequate rest to manage the workload and the recovery status within the body. Something called as flat loading is there, where it is more of a 2:1 kind of a structure that is followed. So, another important concept that is important for the athlete to be ready to perform at the required time, that is optimizing the performance readiness, is called as tapering. What do you mean by tapering is that unloading or decreasing the load in such a way, tactically in such a way that it helps in compensating better and improving the performance during the competition. So, that is called as tapering. It is the primary goal to dissipate the accumulated fatigue while maintaining also the sport specific fitness, that is preparedness. So, you are basically trying to increase the preparedness, as we saw in the different theories that we discussed. So, the optimal duration for this particular effect to take is 8 to 14 days. So, generally tapering concept is utilized just 2 weeks before the competition. So, it is mainly done by the loading manipulation, wherein you drastically reduce the load from about say maximal to supramaximal load to about 40 to 60% in terms of their volume. The intensity can be maintained or slightly reduced, but then volume is drastically reduced. So, this gives adequate time period for the human physiological system to kind of recover. So, that helps in a better state of readiness and preparedness. So, that is called as tapering. So, to summarize, it is important to integrate the concepts of periodization to have a peak performance when you are designing a conditioning program. So, integration in terms of physical, technical, tactical, psychological and nutritional training factors is the key. You have to use the concept of phase potentiation, individualize the load management. To manage load, then you need to monitor them. You need to monitor both the external load as well as the internal load. So, external load in terms of the workload, internal load in terms of the physiological monitor like heart rate, sleep and other aspects. So, this ratio has to be maintained to reach at that sweet spot, so that the load is managed properly for adequate performance. So, achieving the peak again by using the concepts of tapering to peaking at the right time to improve the readiness. And training using periodization model helps in overall athlete development over a period of time. That should be the endeavor whenever you are kind of designing a program. It should not be short sighted, it should be kind of having a broad overview over a long period of time. Following this principle will help in kind of maintaining the athletic potential for a sustained period of time. So, for those of you who are interested in further in-depth reading, you are directed to these references. Thank you and Jai Hind.